Okay, number 11 is going to be either a tangent graph or a cotangent graph. With these graphs, we have a different process for solving them than if we have sine or cosine. First, what we notice here is the period for tangent and cotangent is pi over b. That's the formula that we're going to use. B is the number that's in front of the x. So if you get a problem in the test that has a number in front of the x like that, then this is the process that you're going to do for that. I'm going to show you two different types of problems. 11a is going to be one that has a number in front of the x, and 11b is one where we have a 1 in front of the x, but there's a plus or minus something afterwards. Both of these require two different approaches. So this one is the approach that you're only going to use if you have a number in front of the x that's not a 1. Then you're going to do this process I'm going to show you here. In this case, we have to figure out what the new period is if you have a number in front of the x that's not a 1. To do that, we're going to take pi divided by 2 pi over 3, and that means that we take pi and we're going to multiply it by the reciprocal. And so we're going to multiply this by 3 over 2 pi, and of course when we multiply that, the pi's will cancel and we'll get 3/2. Now I'm not so much concerned about the number I get in the end. I'm actually concerned about this number right here. The number that I'm multiplying by, that's in the box right here, I refer to it as a scale factor. Now the book doesn't really refer to it that way in online homework, but that's technically what this is. You're multiplying the original pi, and it's going to give you a new graph because you're multiplying the original period by 3 over 2 pi. The same thing that we do to the original period, we want to do that to all the key points for the original tangent graph. Now in the notes, I gave you the regular key points for a regular tangent graph. So it was just tangent x only. Here's what the key points would be. Negative pi over 2, 0, pi over 2, pi, and then 3 pi over 2. This would be the key points for a regular tangent graph. Now what we're going to do is we're going to take all the key points for the original tangent graph and multiply them by the scale factor. And the scale factor again is the number I'm multiplying by pi, 3 over 2 pi. So for all these, I'm going to take negative pi over 2 and multiply it by 3 over 2 pi. I'm going to take 0 times 3 over 2 pi, pi over 2 times 3 over 2 pi, the pi times 3 over 2 pi, and the last one is going to be 3 pi over 2 times 3 over 2 pi. So I'm going to multiply all those out. Okay, so every one of those I'm multiplying by 3 over 2 pi. That's going to end up changing all these original key points into the new ones. So whatever I get when I multiply all these, that's the new key points that we'll have for the graph. For this one, I get negative 3/4. I get the pi's are going to cancel out, and I get that. Next, I'll get 0. This one, the pi's will cancel out again. I'll get 3/4. This one here is going to be this 3/2. And the one in the end, the pi's will cancel out. Multiply across the top, across the bottom, get 9/4. Now, the rest of it, we're going to, now the graph itself is going to have these down here as the new key points instead of the original ones here. So we want to use this bottom row to use for our graph. So I'm going to erase all this so we have room for the graph. I'm going to leave the key points just like that and then just draw in the graph. Okay, so I've got each of these on number line. The first one, the middle one, and the last one is always going to be your vertical asymptotes because that's how the regular one was that I gave you in the notes. So the first one, the middle one, and the last one are going to be the vertical asymptotes always. Now of course we have our y-axis is going to come through here because that's at 0. Okay, and then where the midpoints are here between the vertical asymptotes, that's where the graph crosses the x-axis. So that's the x-intercept there for each one of these. Now normal tangent graph looks like that, looks like a cube-shaped graph like this, like a cube, but because I have a negative there, the graph actually flips. So instead, the graph is going to look like that dotted line there. So if we flip the graph over like that, then it looks like the dotted line. So that's what it's going to look like here. So it's going to go through there. So it's going to follow that vertical asymptote. It's going to go through this point here, curve, and go and follow the other vertical asymptote. It's going to do exactly the same thing for this one here. And so this would be your completed graph. We have asymptotes -3/4, 3/4, and 9/4. And then on the 0 and 3/2 itself, we have no pi's down here for this because they all canceled out. We have the x-intercept in between.